done. Okay, now you got it. So let us start with this lesson. Seems that it's a very not like set theory. It's not easy to get like set theory, but we will try to follow this lesson. Very abstract thing, and let us try to do whatever we can with this. I think you are also having surds, yeah. You also have surds, radicals, all kinds of things you are having. So this will be a very abstract lesson. We'll try to do it. Then scientific notation is also there. How to bring things into scientific notation. So a lot of things. It will take some time to finish this lesson. We have to go a little slowly only. Maybe whole month you'll be stuck with real numbers. All right. But once you finish real numbers, after that, what we have, algebra and geometry are the only two lessons that we have. So by January we can be finished with the syllabus, no problem. We can start revising the other lessons. So which school has finished real numbers? Sandhya, you finished real numbers in school?
Yes, uncle, till the omitted portion.
Omitted portion now. Oh.
Yes, uncle.
So what is the omitted portion in real numbers? Well, let us go there and see.
Till 2.5 they completed, uncle.
Okay, in this, now you tell me what all is there. Surds are not there?
No, uncle.
Rationalization of surds not there?
No, uncle.
Scientific notation not there. Okay, only till 2.5 is there.
Yes, uncle.
Okay, let us see. If we'll try to finish everything. Okay, it's not possible. We'll stop with 2.5 till 2.5. What is there? That omitted portion we can do. I have the document with me, correct? Yeah. But anyway, in set theory, anything was omitted? We finished everything in set theory. Now what to think? Anything is omitted. It's too late to ask the question. We know everything now. Okay, let us do real numbers, page 41. Al-Khwarizmi. Al-Khwarizmi. Okay. Persian scholar. See, that means you must have been Muslim, or you must have just become a Muslim. Yeah. Is credited with the identification of surds as something noticeable in mathematics. Okay, so he referred to the irrational numbers as inaudible. Inaudible means what? You cannot hear it. Okay, it is there, but you cannot hear it, like that. Okay, you can say 1, 2, 3, 4, 5, 6. You are telling, no, you are telling some numbers, integers. You are telling. But set theory was dealing only with integers, natural numbers, whole numbers, so very easy. But when you deal with all the real numbers, between 1 and 2, there are so many numbers. And all of them are irrational numbers, which was later translated to the Latin word surdus, meaning deaf or mute. So these numbers means deaf or mute. Therefore, they are called surdus. Therefore, surds. Surds means inaudible numbers, numbers you cannot hear, but they are there. When you tell 1, 2, 3, 4, there are so many numbers in between 1, 2, 3, and 4, which are deaf, and you are deaf to that, you cannot hear them. Like that, you'll have to take it. In mathematics, surd came to mean a root, a radical that cannot be expressed as a rational number. Okay. Root means what? Square root. Why you are telling root? Root means radical. That is come the ground up, it is coming. Okay. So it is a radical number. It is coming from the ground up. So square root, it cannot be spoken of as a rational number. Okay. First of all, before we go to surds and irrational numbers, we have to know that there exist infinitely many rational numbers between the two given rational numbers. This is very important. Between 1 and 2 and 2 and 3 and 3 and 4 or 5 and 6, there are infinitely many rational numbers between 5 and 6. Can you imagine that? Huh? It's a something very hard for us to imagine. You are telling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that you're telling, okay, it's all one, no, nothing is in between. But what you are, if you take off real numbers, rational numbers, between 6 and 7, there is an infinity of numbers. So many numbers. So many numbers, you cannot name them. So many numbers are there between 6 and 7. Then to represent rational and irrational numbers on number line and express them in decimal form. Okay. Expressing numbers in decimal form is also important. All these irrational numbers and rational numbers. Rational numbers and irrational numbers. Okay. See, all the natural numbers, whole numbers, integers, they are all real numbers only. But real numbers are much more than just that 1, 2, 3, 4 or 0, 1, 2, 3, 4 or -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. No? In between 6 and 7, so many rational numbers are there. In between 6 and 7, so many irrational numbers are also there. And you can express them in a decimal form. Okay. And you represent them on the number line. Then we have to be able to visualize the real numbers on the number line. Okay. See, the best thing is you don't use memory, you use your imagination. You must be able to imagination. You must be able to imagine the real numbers on the real numbers made up of both rational and irrational. Okay. On the number line. Then this is advanced. I think for your syllabus, they did only up to here, up to 2.5. But this is advanced to identify surds and to carry out basic operation of addition, subtraction, multiplication, division using surds. Okay. And then to rationalize. That means to make the denominators of surds into rational numbers. And then finally to understand scientific notation. Okay. It's very important, scientific notation, because you will be using it in all other physics, chemistry, everywhere you will be using scientific notation. Physics, chemistry, everywhere, advanced scientific notation. So if you understand it here, then you can understand it when you use it in physics and chemistry. Okay. Numbers everywhere. Okay. Do you have a phone at home? How many digits does it dial have? How many? How many it has? Yeah, digits the dial has. If you have a phone or even a mobile phone. Those days, mobile phone had only okay. Now my mobile phone is having something like this. Okay, so digits are there 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are at least 10 digits there, including 0. What is the pin code of your locality? Okay, somebody tell me what is your pin code? Tell us, Arpana, what is the pin code?
600010.
010. Okay. Oh, good. Ainavaram is 600023, where I live. Although we live very close to each other, the pin code is very different. Okay. When you park a vehicle, you get a token. Okay. On the token, there's some number will be there. What is its purpose? It maps to your car. Okay, unique token. Then have you handled 24 karat gold? How do you decide its purity? This is a question I don't know answer. You have to ask. What is that? Tanuja Jewelers or whatever guy, you have to ask him. Okay, anybody wearing specs here? No.
Oh,
Only I am wearing specs. Okay,
I am
my
also
specs.
uncle.
You're wearing Sandhya.
Yes, uncle.
How much is your power?
I forgot, uncle.
You forgot, huh? Okay, mine is, I think minus 0.5 in one eye and minus 0.75 in another eye. Okay, one eye is this, another eye is this. Okay, so there also numbers are coming. How much water does the overhead tank in your house hold? Oh, that I don't know. Very big tank. Maybe 1,000 liters, or maybe more than 1,000 liters. 1,000 liters is very less. By bucket itself will hold 15 liters. It should be around 1,000 liters plus. Okay, somebody, my cousin had a cousin son, no nephew. He has fever from yesterday. What is the body temperature? Normal body temperature. If you are normal, don't have fever, what is the body temperature? 98.6 Fahrenheit, right? Or 98.8. I don't know. Either 98.6 or 98.8 is the normal body temperature. Now, so far you learn about some types of number like natural numbers, whole numbers, integers. Now you have to extend that idea. Who's putting on that? Excuse me, 1 second. Lydia, who's putting on this radio? Just tell them I'm having class and just switch it on. Rational numbers. Rational numbers. When you want to count the number of books in your cupboard, you start with 1, 2, 3, and so on. So these counting numbers 1, 2, 3 are called natural numbers. You know how these numbers on a line. Okay, that's easy. So you can plot numbers on a line, on a number line very easily. We use n to denote the set of all natural numbers. N equal to 1, 2, 3, we know. Okay. If the cupboard is empty, no books are there, to denote such a situation, what do? You use the symbol 0. So including 0 as a digit, you can consider the number 0, 1, 2, 3 and call them whole numbers. Okay. So from natural numbers, if you include 0, it becomes whole numbers. So the number line becomes like this. This becomes a new number line. Okay. And instead of n, we use w to denote the set of all whole numbers. Whole numbers equal to 0, 1, 2, 3 goes on. 100, 200, 300, 10,000. We keep on going. Certain conventions lead to more varieties of number. Let us agree that certain conventions may be thought of as positive, denoted by a positive sign. The thing that is up or forward or more or increasing is positive. Anything that is down or backward or level or less or decreasing is negative. So you have a minus sign for that. Okay. So you can treat natural numbers as positive numbers and treat them as positive integers. So thereby the entry of negative integers, -1, -2, -3, like that you now have. Okay. -2 is more negative than -1. Okay. You know all that. Therefore, among -1 and -2, you find that -2 is smaller and -1 is bigger. -2 is lesser than -1. Okay. You will think that no, 2 is greater than 1, so minus 2 is greater than minus 1. No, not like that. See the number line. Minus 2 is lesser than minus 1. Minus 3 is even less. Minus 4 is even less. 0, 1, 2, 3, 4. This side only it increases. Okay. So minus 4 is less than minus 3 is less than minus 2 is less than minus 1 is less than 0. So negative numbers, okay, they are lesser. So the number line at this stage is given like this: minus 4, minus 3, minus 2, 1, 0, 1, like that. Okay. Till now you know. And we use Z to denote the set of all integers, including positive integers and negative integers. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, like that. When you look at the figures, okay, 2.2, 2.3, all these figures, look at this figure, this number line. Okay. You are sure to get amused by the gap between any pair of consecutive integers. Could there be some numbers in between? Okay. Is there some number here? Or is there some number here? Is there some number here? The number here? Is there a number here? You think no? You never thought like that. But there is. Okay, there is. You come across fractions already. How will you mark the point that shows half on Z? So this is the number line. 0, 1, 1, 2, 3, 4. Okay. How will you mark the point that shows half on Z? It's just midway between 0 and 1. This is half. So fractions. The same way you can plot 1/3. How will you plot 1/3? 0, 1, 2, 3. 0, 1, 2, 1/3 you have to plot here. Then you can plot 1/4 here. 1/5 will come even slightly more. How will you plot 2 and 3/4? You got 0, 1, 2, 2 and 3/4. This is 2 and 3/4. Okay. Now all these are fractions of the form A by B. That's very important. Where A and B are integers. With one restriction that B is not equal to 0. Denominator not equal to 0. Okay. So 3 by 0 is not what we want. That's not a fraction. Okay. 3 by 4, yeah, that is fraction. Because of the connection between fractions and the ratios of lengths, we name them as rational numbers. Rational numbers. Okay. Where does it come from? The fractions are connected with the ratios of the lengths. So rational, ratio. Okay, that is why we are telling they are in ratio. So they are called rational numbers. Okay, now you got a new line. This is very more complex line than all the other lines that you had till now. Let us look at this line. -7, -6, -5. Look at this number, -4.3. Okay, it is lying between -5 and -4. Then -1. Look at -0.5. It's lying between 0 and -1, exactly in the middle between 0 and 0.1. Okay. Then look at +0.5. It's lying between 0 and 1. Then look at this number, 4.8. It's lying between 4 and 5. Okay, 0.8. Now a rational number is a fraction indicating the quotient of two integers. Okay, quotient means dividing. Okay, you divide, let us say you divide 4 and 4/5. Okay, it becomes an improper fraction, 24 by 5. 4 and 4/5 is an improper fraction, 24 by 5. This is of the form A by B. B should not be equal to 0. So this is a real rational number. The quotient of two integers, 24 by 5. 24 by 5, if you actually get the quotient, you will get 4 and 4 by 5. Okay, this is the quotient Q. Since a fraction can have many equivalent fractions, There are many possible forms for the same rational number. Okay. Many equivalent fractions. You can have 1/3, you can have 2/6. Just multiply by 2, multiply by 2, 2/6. Multiply by 2, multiply by 2, again 4 by 12. Again, if you divide, it's become 1/3 only. But you can express it as 2 by 6. You can express it as 4 by 12. You can express it as 3 by 9. All these ways you can express it. Okay. So the denseness property of rational numbers is an important thing. Consider A, comma B, where A is greater than B. So A is on the right hand side of B. And their arithmetic mean is given by A plus B by 2. Correct. Arithmetic mean is always given by A plus B by 2. Is this arithmetic mean a rational number? Oh, he is asking one question. Because rational numbers are of the form A by B. Here you have something A plus B by 2. Denominator is not 0. So denominator is okay. Numerator must be also an integer. The numerator is an integer, then it is a rational number. So let us see, if A is equal to P by Q, P and Q integers and P not equal to Q. So A is a fraction, proper fraction. B is equal to R by S, that is also a proper fraction. Okay. Then A plus B by 2 is equal to P by Q plus R by S by 2. Okay. Now what you do? You take the LCM. LCM for this P plus Q and R by S is QS. Okay. Multiply by S, multiply by S. This will become PS. Here what you have, multiply by Q, multiply by Q, sorry. It will become RQ. Okay, RQR as it's telling. Okay. So now you see something, QR. P is integer, S is integer, Q is integer, R is integer. So this also integer, this also integer. Integer plus integer is equal to integer. This also integer. So you get the form integer divided by integer. Okay. And denominator already 2 is there. So this 2 is there. 2 into another integer is also integer. So this is of the form A by B. Okay. So that is a rational number. That's what you are trying to prove here. Now, what is telling, this is a rational number. First question answered. Is it a rational number? Yes, it is a rational number. The other question you have to ask is, we have to show this rational number lies between A and B. Otherwise, it is not the arithmetic mean of A and B. Okay. Let us say 4 and 10. Arithmetic mean of 4 and 10 is 10 plus 4 by 2. 14 by 2 is equal to 7. Okay, which is another integer. Okay. Now, this is an integer. You can also have rational number. 10 plus 3 by 2. 13 by 2 is equal to 6.5. Okay, 6.5. Okay. This is of the form A by B. Okay, we have proved that. But now what you have to prove is A by B is lying between the line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is 10. 1, 2, 1, 2, 3. This is 3. Make it 0. And we are going to say 6.5. 1, 2, 3, 4, 5, 6. So this is 6.5 or 13 by 2. We have to prove it is between 3 and 10. A minus A plus B by 2. Okay, first what we are doing, 10 minus this mean number, 10 minus 13 by 2, you have to take first. Okay, like that, no? 10 minus 13 by 2. This, how much you are finding? This length you are going to find out. A minus A plus B by 2 is equal to, this to multiply, this is by 1. A by 1 minus A plus B by 2. So LCM is 2. LCM is 2. This will be into 2 into 2. That will be 2a minus a. Remove the minus a minus b. 2a minus a will be a minus b by 2. Okay. A minus b by 2, which is greater than 0. Huh? It's greater than 0. Positive number. Why? Because a greater than b. You saw, no? Where a greater than b. A is the bigger number. A is like 10. B is like your 3. Okay. So a minus b by 2 is what you are getting. Now, a minus b by 2 will be lesser. Therefore, a is greater than what you are telling here is a minus the arithmetic mean is greater than 0. You have proved that. Therefore, a is greater than arithmetic mean. Okay, you take this the other side. What is arithmetic mean? A plus b by 2. So a is greater than a plus b by 2. This is what you have proved here. Okay, you have proved here. Are you able to understand? This proving and all you don't need, but if you for you to understand, I am giving you. Okay. Then do this side. This side. 3 to 6.5. This line. This length you have to now find out. Okay. For that you have to do 6.5 minus or 13 by 2 minus 3 you have to do. Okay. That is what they have done here. 13 by 2 minus 3. That is a plus b. This is the arithmetic mean again. So a plus b by 2 minus b. Again you take LCM. LCM will be 2 minus 2b. 1 into 2, 1 into 2. Okay. This will be a plus b minus 2b. That is a plus b minus 2b is equal to a minus b by 2 again. Okay, this is correct. A minus b by 2 will again be greater than 0 because a is greater than 0. This is 10 is greater than 3. Okay, so this will again be positive. So it's again a positive number. Okay, so a is greater than a plus b by 2. Sorry, a minus b by 2 is greater than 0. Therefore, a plus b by 2 is greater than b. And this is b. See, a minus b by 2 is positive, which means a plus b by 2 minus b is positive. Therefore, this is greater than this. Otherwise, you will not get positive. You understand? Only if this is greater than this, you will get it is greater than 0. It is greater than this quantity is greater than 0. So, this first one, whatever it is, let us say x. If you see x minus y is greater than 0, that means x is greater than y. So, a plus b by 2 is greater than b. Okay, that is how you are arriving at that a plus b. So, what you arrived now? You arrived at two things. A is greater than a plus b by 2. Okay, and a plus b is greater than b. This is what you arrived. Two things you arrived. Okay, which means, okay, so this is what you arrived. So you can visualize that as follows. How to visualize that? There is b, there is a, and then a plus b by 2 is in the middle of this. Okay. Now this one, this is what I told. You can visualize this as 10. You can visualize this as 3. You can visualize this as 13 by 2. 13 by 2 is in between 10 and 3. Okay, exactly in the middle. So for any two rational numbers, their average or midpoint is rational. This is the most important thing. Any two rational numbers, their average or midpoint is also rational. Okay. Now here I took only integer and I took another integer. Okay. But this became a rational number. Integers are also rational numbers. They can be expressed as fractions, 10 by 1 or 20 by 2. Okay. 3 can be expressed as 6 by 2. Okay. So whenever you can express any number in A by B form, it is a rational number. So 10 is also a rational number, 3 is also a rational number, and 13 by 2 is also a rational number. So what is the learning that we are getting? The most important thing you are learning is, for any two rational numbers, their average or midpoint is also a rational number. Ratio. So half the ratio. This line half the ratio. This line another half the ratio. So that is a rational number. Because, okay, like that it is coming. Find any two rational numbers between half and 2/3. This is a very important thing. Find any two rational numbers between half and 2/3. Okay. First solution is a rational number between half and 2/3 is equal to, what you can do? You can immediately apply the average. Okay. Half 2/3 divided by 2. Get the average, it will be in between. It is going in between. Okay. You take LCM for the first one. LCM is 6. For 2 and 3, LCM is 6. Okay. This into 3 into 3. So, 3. This into 2 into 2 plus 4. Okay. Divided by 2. 7 by 6. Okay. Divided by 2. That is equal to 7 by 6 into half. Divided by 2 into half. Okay. That is 7 by 12. So where is 7 by 12? 7 by 12 on your line, 0, 1. Let us take this is 0, this is 1. Okay, this is half. This is half. This is 2/3. This is 2/3. 7 by 12 is exactly in the middle. 7 by 12 is exactly in the middle. Okay, so this is also of the form A by B. So another rational number you have got. Rational between half and 7 by 12. Now they are telling what you find. Find any two rational numbers between half and 2/3. Any two they wanted. Only one you found out, that is 7 by 12. Okay. Now what you are doing, let us take this is half. And let us take this is 2/3. Okay. Now you have 7 by 12 at the exactly the middle. Okay. Now what they are telling, you can find the number that is exactly in the middle between half and 7 by 12. This number you can find out. Exactly in the middle between half and 7 by 12. So half plus 7 by 12 divided by 2. Average arithmetic mean of these two. Again 12 is here. LCM 12 into 6 into 6 you get 6. Okay, into 1 you get 7 divided by 2. So 13 by 12 into half. 13 by 24. Okay, this number is 13 by 24. Now what you got? Two numbers between half and 2/3. That's what they wanted. Two rational numbers between half and 2/3. Okay, first number is A1 by B1, 7 by 12. Second number is A2 by B2. Okay, 13 by 24. You got two numbers now. You understand? Both these numbers are between half and 2/3. Very interesting. Like this, you can keep on finding rational numbers between half and 2/3. So there is an interesting result here now. You can help to write instantly you can write rational numbers between any two rational numbers. Just find the arithmetic mean and put it there. Very simple. Okay. Now he's giving a rule now. Based on this, he's giving a rule. If P by Q and R by S are any two rational numbers such that P by Q is less than R by S. Okay. You take a straight line. So take a straight line. We had half and 2/3. Okay, you represent this by P by Q, and you represent this by R by S. Okay, this is R by S. Yeah. P by Q is less than R by S, correct? Yeah, then P plus R and Q plus S by is a rational number. It is simple, they are giving a simple solution. And this P plus R and Q by S is less than R by S. It is inside between them, it is between them. So one simple number, any two rational numbers, okay, then you can get another rational number in between them by P plus R by Q plus S. Okay, very simple. How they arrived at that? Let us take the same example. Find two any rational numbers between half and 2/3. Same example. This is P by Q. This is R by S. Okay. What you have to do? P plus R. 1 plus 2 divided by 2 plus 3. 3 divided by 5. Okay. 3 by 5. You got 3 by 5. Okay. You got 3 by 5. Very simple. Now, you want to find two more numbers. Now, between half and 3 by 5. You want to find two numbers between half and 3 by 5. Now, add this one. This is P by Q now. This is R by S now. Now, you get P plus R. P plus R 1 plus 3. Okay, P plus R 1 plus 3. Then Q plus S. Q plus S is 2 plus 5. Okay, this has become 4 by 7. Okay, now you got 4 by 7. See, now you got 4 by 7. So half 4 by 7, 3 by 5. In the same way, you want to find some number between 3 by 5 and 2 by 3. Okay, 3 by 5 and 2 by 3. You want to find some number. This is P by Q. This is R by S. P plus Q, 3 plus 2, 5. Okay, Q plus S, 5 plus 3, 8. 5 by 8. No, so 5 by 8 is something that is coming. So like that, no, you can take like that very simply. Instead of finding arithmetic mean, here they are giving a shorter method, okay, which is a solution 2. Solution 1 is find arithmetic mean. Take the two numbers P by Q and R by S, add them together and divide by 2, find the arithmetic mean. That is one way. The other way is add P plus R and add Q plus S. Okay, that is a new number. Okay, like same way you can go on. So that is solution number 2 that you have found. Okay, it's more simpler solution. You are getting it? I don't know how your school teacher took this lesson for you. This is a very complex lesson. Okay, and you have to go very slowly. Otherwise, you will not understand. If you are going like set theory and all, it won't work out. This is a very important lesson. Okay. Are there any more methods? Yes. If you use decimals, then the observed example can be given an alternate solution. Using decimals, you can have alternate solution. Okay. So half is now converted into 0.5. You know that. And 2/3 is converted into 0.66666. It will keep on going. Okay, you know that. Hence, rational number between half and 2/3 can be listed. No, very easily now you can list many number of rational numbers. 0.5. This is where the number is starting. 0.667. This is where the number is ending. So 0.52. You can have one number here. Then 0.57. You can have one number here. 0.60. You can have one number here. 0.63 you can have a number here. See, so many numbers you can have. Okay, if you take the decimal root, many numbers can have. Okay, that is one solution also. That is one solution. Okay, that is also easy solution, like solution 2. Then they are telling there is one more method, final method. There is one more way to solve some problems. For example, to find 4 rational numbers between 4/9 and 3/5. Okay, now number line is like 4 by 9. and 3 by 5. Okay. To find 4 rational numbers between 4, note that the LCM of 9 and 5 is 45. Okay. So 9 and 5 LCM is 45. Based on that, what they are writing? They are writing 9 as based on LCM. Okay. 4 by 9 becomes into 5 into 5. 20 by 49. Okay. 4 by 9 becomes 20 by 49. And 3 by 5. Again, 3 by 5. You have to get it into 45. How much? Into 9 into 9. 3 9s are 27. Okay. So 20 by 45 and 27 by 45 is there. Between this line and this line, 20 by 47 and 30. So now you can put 21 by 45, then 23 by 45, and 25 by 45, 26 by 45. You can put like that. Okay, see? So that is another way. Take the LCM note out. Okay. This will give you limited number of options. 4 or 5 rational numbers if you want, you can take. But more numbers you cannot take. Okay. That's one thing. So all these methods are clear. If all these methods are clear, then let us go and try example 2.1. And I think we should finish with example 2.1 if we can. Okay, you tell me. I think I've shared. Okay. Which arrow best shows the position of 11 by 3 on the number line? A, B, C, or D? Which one? 11 by 3. First, convert it into a proper fraction. It's an improper fraction. Convert it into proper fraction. How much is the proper fraction? What is the proper fraction for 11 by 3? Somebody tell me. Are? You're all keeping silent. Sandhya, tell me, proper fraction for 11 by 3. 3 and? What happened? 3 and 2/3. Correct. இதெல்லாம் 6ஆம் கிளாஸ் 7ஆம் கிளாஸ் 8ஆம் கிளாஸ்ல படிச்ச மேத்ஸ் நான் புதுசா கேட்கல. What is the proper fraction for 11 by 3? This is 3.667. Correct. 3.667. Now you tell me which one is the correct answer. A, B, C, or D?
C, no, D, uncle.
3 point
D, uncle.
D. Yes, D or D is correct. 3.667. This is 2/3. Okay. This is 1/3. 3 and 1/3. This is 3 and 2/3. So what we are getting is 3 and 2/3. Okay. Correct. Very good. That's some we have finished. And this is exercise 2.1 now. Let me open up. Okay. Now clear all drawings. Okay. Find any 3 rational numbers between -7 by 12 and 2 by 11. Okay, let us go and put a line and you can say it here. It's easy sum, but still we will do it here. Line is there. -7 by 11 is there. This is one point. Then the other point is 2 by 11 is there. Okay. Now you tell me 3 rational numbers between -7 by 11 and 2 by 11. Anybody? 4 numbers. Each of you tell two numbers.
-6 by 11.
Okay, -6 by 11. Tell me something positive number, Sandhya.
-1 by 11.
Okay, -1 by 11. Okay, Arpana, you tell me 2 numbers. Tell me some positive numbers. 15, 7.
0 by 11, 1 by 11.
0, 7, 1 by 11. Okay, very good. 0 by 11 is 0. Okay, very good. Okay, that is also very good. This is exercise 2.1, second sum. Okay, exercise 2.1. We have to do the third sum now. Good, good. Find any 5 rational numbers between 1/4 and 1/5. 1/4. Okay, this is 1/5. This is 1/4. Okay, this is R by S, R by P by Q. This is R by S. You want to do that method or you want to do any other method? You tell me. Which method, Sandhya, you want to do to find 5 rational numbers? Quickest method is P by Q, R by S. La? Which method you want to use and then tell me find 3 rational numbers. Sandhya, which method you want to use? P by Q and R by S method, huh? Or you want to use common denominator method?
We will use P by Q, uncle.
Okay, that is solution 2 you are using. Okay, this is P by Q, that is R by S. Now you tell me one number between 1/5 and 1/4. How much? How much, yeah?
6 by 5.
6 by 5, yeah. P plus R, sorry. P plus R by Q plus S, sorry. Q plus S. Tell me. Tell me. P plus R.
1 by
P plus
9.
R. Oh my God. Very simple, yeah. Tell me. How much is P plus R?
2
2
by 9.
2 by 9. Yes. So that is 2 by 9. Now tell me, they said how many numbers you have to find out?
5.
5. Okay, one is found out. Sandhya, you tell me next number. This becomes R by S. You tell me next number.
Uncle, I already
Plus
told
R.
you.
Oh, Arpana. Okay, Arpana, you tell me. Now it is 1/5 and 2 9. R by S is 2 by 9. P by Q is 1/5. Now you tell me what is P plus R.
Plus R is 1 plus 2, uncle.
Okay. Fast.
5 plus 9.
5 plus 9. How much?
3 by 14, uncle.
3 by 14. Okay. 2 numbers you have found out. Now new one. 1/5 and 3 by 14. This is P by Q. This is R by S. Okay, Sandhya, you tell me. P plus R by Q plus S.
4 by 19.
Very good. Okay, Arpana, you tell me now. 1/5 and 4 by 19. One more number.
5 by 24, uncle.
Very good. 5 by 24. Okay, on this side, somebody tell me. 2 by 9 and 1 by 4. Sandhya, you tell me. Last number, let us find it on this side. 2 by 9 and 1 by 4. How much?
3/13.
So this is coming on 3/30. Okay, that's all we can do today. We finished it, and you go and enjoy your Diwali today. Friday, Diwali holidays. Okay, not today Diwali holiday. Today no holiday. Friday we'll have Diwali holiday. We'll meet again on Monday then. Huh? All right,
Yes,
guys.
uncle.
Okay. Read something on irrational numbers and come.
Okay, uncle.
Okay, that will be homework. No exercises to do, but you can read something. There's a lot. Okay. Yeah. Very good. Today you did excellent. Thank you very much. Bye, guys.
Bye, uncle. Happy Diwali, uncle.
Hey, happy Diwali, guys. Yeah. Tell your dad, mom also, Sandhya. Happy Diwali.
Okay, uncle.
Holidays also.